You know that feeling when you're absolutely sure about something, and then one new piece of information comes along and just flips everything on its head? Well, believe it or not, there's actually a mathematical formula for that exact process. Today, we're going to break down the elegant, powerful, and honestly kind of mind-bending formula that teaches you how to update your beliefs.
Okay, let's just dive right in with a scenario. Picture this. You go in for routine medical screening. You feel totally fine, but a few days later, the phone rings. And the news is, well, it's alarming.
So, here's the puzzle we're going to tackle. The test they used is known to be highly accurate. You tested positive, but the disease itself is super rare. Your mind is probably racing, right? What are the odds you actually have it? Just take a second. What's your gut telling you?
Now let's put some real numbers on this. First, the disease is incredibly rare. We're talking 1 in 2,000 men over 50. That's just 0.05% of the population. Second, the test is pretty darn good. It catches the disease 90% of the time in people who actually have it. And finally, it has a really low 1% false positive rate. That means it only messes up and flags a healthy person 1% of the time.
So with those numbers, especially that 90% accuracy, it feels totally logical to assume the chance you're sick is also around 90%, right? I mean, the test is accurate and it says you have it. But this, my friends, is where our brains can play tricks on us.
Let's dig into why our intuition gets so tangled up by this kind of problem. And don't worry, it's not just you. This happens to pretty much everyone, even the experts.
And I mean that literally. This isn't just some abstract thought experiment. A study gave a very similar problem to a group of doctors. They asked them to estimate the chance of having cancer after a positive test result. And a staggering 95% of them got it wrong, guessing the odds were about 75%.
The real probability in that study, it wasn't 75%. It was 7.5%. That's a full 10 times lower than what most of the doctors thought. It's a perfect example of a cognitive blind spot we all share.
So what's happening here? Our intuition zooms in on the big, flashy number, the test's high accuracy. It's dramatic. But what we fail to really appreciate is the starting point, the base rate. The simple fact that the disease is incredibly rare to begin with. And that rarity, it turns out, has a way bigger impact on the final answer.
Okay, so if our gut feeling is leading us astray, how do we get to the right answer? Well, thankfully, there is a tool designed for exactly this. There's a formula for updating our beliefs when we get new information. And here it is. Say hello to Bayes' theorem. Now I know, it looks a little intimidating with all the P's and brackets, but the idea behind it is actually beautiful and simple. It's just a formal way to figure out the odds of something given some new evidence.
Let's forget the math for a second and just think of it like this. Bayes' theorem is a belief-updating machine. That's all it is. You put in what you used to think, you add your new evidence, and it spits out a new, more accurate belief.
The machine has 3 basic parts. You start with your prior belief. For us, that's the fact that this disease is super rare. Then you add your new evidence, which is the positive test result. The machine crunches those 2 things together and gives you a posterior belief, your new, updated, and much more accurate probability of being sick.
All right, theory's great, but let's see this machine in action. We're going to go back to our medical mystery and use this new way of thinking to finally find the real answer. Instead of just plugging numbers into the formula, let's actually visualize it. It makes it so much easier to understand. Imagine a big group, say 200,000 men over 50, and they all take this test. Okay, so let's break it down. Out of our 200,000 people, we know that only 100 of them will actually have this rare disease. That leaves 199,900 who are perfectly healthy. Now remember, the test is 90% accurate. So, of the 100 sick people, it'll correctly identify 90 of them. Those are our true positives. But here's the kicker. That tiny 1% false positive rate, when you apply it to the huge group of healthy people, it creates almost 2,000 false positives. And that is the whole secret right there. The pool of healthy people is just so enormous that even a tiny error rate produces a mountain of false alarms. That mountain of false positives completely dwarfs the small number of true positives. Your positive test puts you in a group of over 2,000 people, but most of them are actually healthy. So to find your specific chance of being sick, the calculation is actually pretty simple. You take the number of people who were genuinely sick and got a positive test. That's our 90 true positives. Then you just divide that by the total number of people who tested positive for any reason, which is 2,089.
And when you run that simple calculation, you get your answer. It's not 90%, it's not 75%. The real, actual probability that you have the disease is just 4.3%.
Just let that sink in for a second. A test that's 90% accurate gives you a result that means you only have a 4.3% chance of being sick. This shows you the incredible power of thinking with base rates. A positive result doesn't automatically mean you're sick. It just means you've moved from the general population into a smaller, higher-risk group. But that risk is still way, way lower than our intuition tells us.
So, this is obviously more than just a clever math trick. This whole approach, this Bayesian reasoning, it's a powerful mental model you can use for pretty much anything.
And once you start looking for it, you see this kind of thinking everywhere. Your email spam filter uses it. Weather forecasts are constantly updating the probability of rain with new data. It's used to weigh evidence in courtrooms, it powers search engines, and, of course, it's at the heart of modern medical diagnoses. At its core, all this is a structured way to learn. It's a system for combining what you already know with what you've just learned. It stops you from jumping to conclusions and forces you to weigh new evidence properly.
So the big takeaway here is this. Start with what you believe to be true, your base rate, but always be ready to update that belief when new evidence comes in. It's about being humble enough to know that you might be wrong and disciplined enough to change your mind.
And that leaves us with one final question to chew on. What's a belief you hold really strongly right now that might need updating if you were presented with one powerful new piece of evidence? It's a heck of a question, and now you've got the formula to help you find the answer.